A practical topic concerning electrochemistry is corrosion prevention. So, our objectives. We will define corrosion and list methods to prevent or slow corrosion. So those include things like paint, alloys, galvanization, and cathodic protection. We are all abundantly familiar with corrosion, which is the degradation of a metal by naturally occurring electrochemical processes. Familiar examples include rust, the blue-green patina that forms on copper. If you've ever seen a copper roof, it looks that blue-green. Black tarnish on silver, which you are forever cleaning off. Corrosion in marine environments where there's plenty of ions to facilitate continued redox reactions is really difficult to stop. So anyone who lives at the shore can vouch that your doorknob will corrode over time no matter what you do to prevent it. Your car will wear more quickly due to rust. We cannot stop corrosion. We can only hope to slow it down. So how do we protect from corrosion? Our primary line of defense is paint. The United States Navy aggressively paints their ships to prevent corrosion. Once they finish the entire ship, they start all over again. 1/3 of the life of a ship is spent in dry dock for maintenance, and one of the things they regularly do is add another coat of paint. Why? Paint is much cheaper than replacing the hull. If you have ever toured a decommissioned naval vessel, you can sometimes see a place where a collision has happened which chipped off all the paint layers. They can literally be inches thick. We also use paint on our cars, which is probably where you're more familiar with that strategy. Alloys, including stainless steel, can be formed to create a protective oxide layer on the outside of materials. That prevents oxygen species from reaching the rest of the material. So in the case of stainless steel, that is made of chromium, so chromium oxide forms, and it prevents the rest of the iron in the mixture. Galvanization is the addition of a thin layer of metal which has lower reduction potential than most materials, so therefore oxidation becomes unfavorable. Usually galvanized materials have a thin layer of zinc on the outside. Finally, there is cathodic protection. It's the use of a metal with a cell potential that is lower than the protected material. This makes the protected material into the cathode if you're going to have it happen spontaneously. Because remember, we need E cell to be positive, and if we're subtracting something that is a smaller number, we will get a positive number. So here we have an example of cathodic protection on a boat. That's what this picture is. That gray bar is a metal that is acting as cathodic protection. So in the next slide, we'll cover this in more detail. Here we go. Galvanization is the use of an outer coating that is much more oxidizable, often zinc. The coating reacts instead of the central material. So zinc oxide, turns out, has still many favorable properties after it's been oxidized. For example, it does not become ridiculously brittle, so it remains on the outside of object it coats. Cathodic protection, on the other hand, makes the vulnerable metal the cathode. So if redox happens, it gets a thicker coating of metal instead of going away into solution. The anode, which is sometimes called the sacrificial anode, becomes ions. The protection material has lower reduction potential than the metal it is put inside, so that it degrades instead of the other material. So above is a picture of a sacrificial anode that has been used in an underground oil tank. You can see that the material is deeply pitted and pretty thin. It needs to be replaced. Sacrificial anodes are also used in water heaters, boilers, and underground storage tanks. They must be regularly replaced in order to be effective. So this is something that requires frequent maintenance, but it's less expensive than literally digging up an entire oil tank in order to replace the entire thing, along with whatever oil spilled. To summarize, corrosion is the spontaneous oxidation of various metals via redox reactions. Corrosion can be prevented using paint, alloys, including stainless steel, which provide a layer of oxide that prevents oxygen or water from reacting with the underlying material. Galvanization, which is a layer of material that acts as an anode instead of the underlying material. And cathodic protection. So the protection material is oxidized and degrades. That's the sacrificial anode. And the protection material must be regularly replaced.